Okay, so yesterday we talked about solving systems of equations by plugging in an ordered pair and determining whether or not that ordered pair was a solution to the system of equations. Today, we're going to solve linear equations in two variables by using substitution. So what you should know by this point is that, let me pull up a blank slide for you guys. You should know, hold on, by this point, oh, there's a little plus sign right there, sorry. Okay, you should know by this point that when we say y equals 6x, if I were to tell you that y equals 2x plus 4, that both of these y's are equal to one another. So I could say 6x is equal to 2x plus 4. We should all remember that from when we solved for x 9,052 times when we were talking about solving for equations. All right, going back, let me make this big for you guys at home. All right, so when we solve for systems of equations by substitution, there are 5 various steps that you guys need to be aware of, and kind of you can tick them off one by one. I do this in my head as I do these. I'm 30 years old and I still do this when I solve for systems. So the first step, solve for one variable in at least one equation if necessary. You can solve for x or y. You get to choose. You get to make the choice here. Okay? The second step is substitute the resulting expression into the other equation. An example of that would be if I solve 2x plus 4 equals 2y. I solve for this. I get that y is equal to x plus 2. I could take this x plus 2 and put it in for y in a different equation. All right? Step 3. Solve that equation to get the value of the first variable. Well, that's just plugging in. We're going to do some examples of these. I'm just walking you through the steps right now. Step 4, substitute that value in one of the original equations and solve. We're going to be determining whether or not that substitution will give us an ordered pair that works. Here, let's walk through one together. The first example is the system y equals 3x and y equals x minus 2. So the first thing I'm going to do, step 1 over here, is solve for one variable, at least one equation if necessary. Well, I look over here and I see that I already have that y is equal to 3x or y is equal to 2x minus 2. So they're both already solved. So what I'm going to do now is I'm going to help you guys out by saying, okay, well, if I have y is equal to 2x minus 2, why can't I just put that in for this y? And that's what I'm going to do. So I'm going to say x minus 2 is equal to 3x. All right, so the first thing I did was I saw that they were solved for y. Step 2, substitute the resulting expression in the other equation. Boom, just did it. Step 3, solve that equation to get the value of the first variable. So now all I have to do is solve, and we're brilliant at this because we've done it so frequently. I'm going to divide everything by 3, and I'm going to get that 1/3 x, did I do that right? Minus 2 equals 3. Oh, I never combine my like terms. All right, well, amateur mistake. Hold on. Hold your horses at your house. Amateur mistake, sorry. Okay. Yeah, it would have just been several more steps. It's easier if I just go back and say x minus 2 is equal to 3x. Subtract x from each side. Negative 2 is equal to 2x. Divide both sides by 2. Negative 1 is equal to x. Okay, so now that I've got that, I solved the equation to get the value of the first variable. Awesome, we have that x equals negative 1. So now the next step is substitute that value into one of the original equations and solve. Does it matter which one of these equations I plug this x equals negative 1 into? No, the answer is no, because if I say that y is equal to 3 times negative 1, if these two things are both equal to y, then when I plug in y is equal to negative 1 minus 2, I should get the same answer. Y equals negative 3, y equals negative 3. This is correct. So where x is negative 1, y is negative 3, giving me the ordered pair negative 1, negative 3. And this is a solution to this system by substitution. Let's try another one. Solve one variable for at least one equation. This one's already done for y equals. So I'm just going to plug that in. 4x plus this y is equal to 1x plus 1. I'm just going to plug that in right there. X plus 1 equals 6. So I'm just going to solve for x. This is 5x plus 1 equals 6. This is 5x is equal to 5. X is equal to 1. So now I'm just going to plug in and make sure that that's true. So that would give me the ordered pair 1, comma, well, let's find out. Y is equal to 1 plus 1, and 4 times 1 plus y is equal to 6. Y is equal to 2. If this is true, then whenever I solve this equation right here, I should get y is equal to 2. 4 times 1 is 4, plus y equals 6. Subtract 4 from each side, y equals 2. Yes, the answer is 1, 2. Here's another one. Now this one is unique because step 1, solve for one variable, at least one equation. I don't have that done yet, so I'm going to have to solve over here for either x or y. Just by looking at these two, I would choose this one because it's easy to solve for x. So add y to each side. In doing so, x is equal to y plus 5. So now I've done step 1. I've already taken care of it. So you guys work through this one on your own. I'm going to come back. Next time you see me, it'll be the answer. Okay, so now I'm showing my work, how I got from the equation x equals y plus 5, plugging it back in for the top equation. Now, Ms. Sokolowski, she asked a really good question. She said, well, why can't I plug back this equation here back in for this one? Why can't you do that? Think about that really quickly. Why can't I do that? Why can't I plug this equation back in for that equation? Because they're the same equation. I have to get where I got x equals. I cannot plug that in for this x. I have to plug it in for the equation that I did not manipulate, the one that I did not change. Okay? So if you did that, well, that's a very common mistake. Now you know you did it. Moving on. All right, I also got the ordered pair 3, negative 2 as a solution. You're more than welcome to come back and watch the video again and kind of work through it. We're going to move on really quickly. The next example gives us something kind of unique, and you'll see why as I work through it. Step 1, solve for one variable and at least one equation. Well, neither one of these are solved for x or y. I'm going to simply take this equation and I'm going to solve for y. Y is equal to negative 6x plus 11. So now that I've changed this top equation, I'm going to plug in for y in the bottom equation. That's going to give me 3x plus 2 times, notice I have to use distributive property because this is saying 2 times whatever y equals. Well, y is equal to negative 6x plus 11, which is all equal to negative 5. So now I get to use my distributive property. 3x plus negative 12x plus 22 is equal to negative 5. I'm going to use combining like terms to get negative 9x plus 22 is equal to negative 5. Subtract 22 from each side. Negative 9x is equal to negative 27, divide both sides by negative 9. X is equal to positive 3. So I'm going to take this positive 3 and I'm going to plug it back in for either equation. I choose the top. Y is equal to, y plus, my bad. So y plus 6 times 3 is equal to 11. Y plus 18 is equal to 11. Y is equal to negative 7? Negative 7. So the ordered pair is 3, negative 7. All right, I'm going to put up a word problem. You're more than welcome to work through it. Come tomorrow to class with some of this worked out or none of it worked out. Either way, it'll be on the board when you walk into the classroom tomorrow.